To get started. So first, I'd like to thank OzLockCon for having me here. My name is Kevin. Today, I'd like to share with you my journey on how to reverse engineer into a smart lock called DogBone. Yeah. So who am I? I'm a security researcher from Vancouver, Canada, and I like to hack in wireless and IoT systems. You are always welcome to follow me on Twitter. And here are the things we are going to cover today. First, I will start with the introduction on some fundamental knowledge of BTLE and then we'll move on BTL locks in particular. And then I will go through all the methods I have used during the reverse engineer from the beginning to the end. And after this talk, I hope everyone can apply the same method for other small locks or similar BTLE devices. The BTLE device has been widely used and getting more popular. But what is BTLE anyway? BTLE stands for Bluetooth Low Energy. It's operating on 2.4 gigahertz. And it has 40 channels, and 37 of them are purely for data transfer, and 3 channels. There's a fixed 3 channels for broadcasting, which is 37, 38, and 39. And the Bluetooth Low Energy also using frequency hopping, so 1 data packet per channel. But the algorithm is really public known. And also for Bluetooth Low Energy, they have a thing called GATT, G-A-T-T. It's actually a profile to define how 2 devices to communicate with each other. So we are able to, the GATT server can actually contain several services, and each service has a group of things called characteristics. For those characteristics, we are able to read and write and notify to it, and also most importantly for us in order to have hacking the BTLE device is each characteristic has a unique UID associated with them. It's actually 128 bit based. So the Bluetooth device uses this particular UID to define what functionalities this device has. And also, Bluetooth Low Energy also implement a certain level of security. They have encryption. They come with encryptions. You actually rely on AES CCM for the session encryptions. However, you notice that on level 1, there's no authentication and no encryption in this level. But happen to be a lot of Bluetooth device by default on this level. They also use pairing, different methods for pairing. The most common one is JustWorks. It's basically using 6-digit zeros, and this is very important for us to hack it later on as well. So also, because for JustWorks, imagine you have the padlock, and there's no way you can tap in or display the current the pairing pin. So they have to find out a way to how to pair, and it's simply by using 6-digit default zeros. And also, we also need to find a way to using the right equipment to communicate with Bluetooth. The most easy one you can find that in this one. Is BTLE dongle. It's super cheap. You can easily find on eBay. I suggest you can grab at least 2 or 4 of them. Also, if you want to increase the range to see more Bluetooth devices, you can use the second one, the UD100. The beauty of this is it has the external antenna connectors, so we can connect in the high-gain directional antenna to see much further away. Or simply you can use just using our mobile phones to communicate with it. And also, if you're really serious about Bluetooth hacking, then I would highly recommend you to buy this device called Bluetooth. I will come to this later again. Also, we now have hardware. We also need the right software. Turns out there are plenty of mobile applications for interactive with BTLE devices already. So I prefer one called Light Blue. And also, if you prefer to use NRF Connect or any other BTLE application, it actually just works fine. But if you want to go deeper, we can also use software under Linux to communicate with it as well. There's something called BlueZ, and BlueZ is really a Bluetooth protocol stack for Linux. It comes with plenty of usable tools already. So one of us like STI2. So we can use STI2 to discover the Bluetooth devices address or some other information. And also we can use another tool called GetTool to actually interactive with the Bluetooth devices. So now we have the right equipment and the software. We need to find we need actually to discover those Bluetooth devices. So we can use in traditional way, just simply using the HCI2 scan to scanning for it. But the problem is the result we get is difficult to pass to analyzing. Now, so I would recommend to using one of the application called Blue Hydra. Blue Hydra is really an air dump like software essentially for but it's dedicated to Bluetooth hunting. So as you can see, this picture here is me and my colleague Yannick built this Bluetooth survey equipment based on Blue Hydra and the Raspberry Pi. We also attach a high gain directional antenna to it, so we are able to increase the range much further away. And these are the sample of work we captured. As you can see, a lot of them turns out to be Apple devices. Right, so maybe general Apple users don't really care about privacy. Yeah. Okay, so now during the year, many researchers has managed to find the vulnerability on so-called smart locks, and this is also the reason why I started the project dog-bomb lock in the first place. So I like to learn and try to my things myself as well. Then here's some of the researcher. Result they published before. Okay, so what kind of vulnerability you can actually find Bluetooth smart padlocks? So it turns out it's quite similar to the networking world as well. So they have plain text vulnerability. We can do the replay attack. We even can forcing it. And this one I found is pretty interesting because they simply send malformed packets to the lock and then lock just simply pop out. So, right? So here comes our main topic today, the dog-bomb smart lock. The dog-bomb lock is actually made by a company based in the UK, and the interesting thing I found that they are mainly to make accessories for mobile phones. They're making phone cases, but now since all of a sudden they want to make smart locks, and just like every smart lock company, they will advertising their products are the most secure one on the market in the market. Cool, but sometimes they go too far. Now this is one of the statements I found from them. So they actually say. Don't worry about the hacking, right? The padlock is so secure. They have the banking level of securities, which that means we actually need Steve Wozniak to actually create cracking it, right? So, okay, so now let's see how is this statement true or not. So the first stage we're going to do some recon. Okay, so. During the recon stage, the most important thing is try to get as many details as possible for our target. So first, we can use HCI. Again, we can use HCI2 or mobile application like the light blue to get some basic information. Now, just by using the light blue, we are already able to find out what kind of servers this this dot bomb logs exposed to us. Yeah. Okay. And also by simply Google search, I found the dot bomb log has been taken apart by a researcher named Ray, and he presented at CCC Congress last year, I think. Here's an internal photo of the dot bomb log from Ray's slides. Based on his finding, the dot bomb logs use the Nordic NRF51822 chipset for Bluetooth communication, and this chipset is one of the most common ones you can find on Bluetooth devices, low energy devices. Again, this is another slide I stole from. And yeah, which explains very clear how smart lock architecture looks like. Turns out it's quite simple. We're using mobile application to talk to the locks through BTLE, and then we talk to the backend server through HTTP or HTTPS. This is very simple. Okay, so now in order to understand deeper how dot bomb locks really works, first thing we can do is take a look at the dot bomb mobile app. Right? The dot bomb mobile app comes with iOS and Android version. By using dot bomb mobile app, we are able to obtain the current battery level and other current status of the lock. We can also open the lock by simply tapping to open, or configure a passcode to unlock it. We're also able to share a lock with the different users, and we are even able to check how many dot bomb locks are currently near us with the Google map. Right? So it's social networks of locks. Yeah, okay. Now, the Android app can be easily decompiled by using software like JD GUI. Now, this is what I found. I think the most developer the mistake they made is because just like the dot bomb application, they don't use any sort of code hardening, no package, no obfuscation for code. So we're almost like once we decompile it, we're almost like read the source code. Now, just by reading through the Java bytecode, we can already learn a lot about dot bomb lock without even having actually physical access to it. Now, the information we can find like what kind of UID is used and what it's for. So this one I found is very interesting. It's a UID for a password. So now, sometimes you may think you're so lucky because they also sometimes they have mistake like hard-coded default password in the code, right? And this guy thinks like F word a lot. But is it a game over already? We found the password now? Actually, it turns out it's not this time. It's actually when the first time user connect to the dot bomb server with their mobile applications, the server will generate a random 40-byte password and send back to the application to replace those default passwords. But actually, it's a 32-byte and 8-byte padding by FF in the end. But now, one more thing worth to mention is this password will only update again when we remove the association between our account and the lock. So now that means they do change the password, but the thing is how many people will remove the lock every time from their account, and then just like you unlock it, you remove the account, the association, and join back again to just further update the password. And by the way, they don't even mention this in the manual, so nobody's gonna know, right? And you may wonder how I found out of this. And it's because even dot bomb application do encrypt with the traffic with SSL, but they forgot to turn on a third panel. And that means we can still sniff in the traffic between application and server with software like BERT or main middle proxy. And the request and the response to or from server are now under our control. And this is turns out very handy for us to analyze the different behavior of dot bomb logs later. So, for example, this one, as you can see, it's clear. But if we have configured to use passcode to open the lock, the server will upstate the actual passcode with cell 256 and send back to us as a current lock status. Now, however, since those passcodes are only used 4-digit numbers, and so that means it's very easy to crack the hash to find the real passcode. Right? So we just simply upload to the online cracking website and then boom, we find it. So, and now if someone doing the middle attack to sniffing our traffic, our passcode is just simply leaked already. And since duck unlock are used Bluetooth to communicate, we will need a way to capture BTLE traffic as well. So, let me miss some slides here, but I'm sure. Let's go ahead. Now, since the duck unlock uses Bluetooth to communicate, we'll need a way to capture BTLE traffic. Now, the first option is to sniffing it through air, which I'm going to mention how later. And another option is in Android 4.4, a higher version. It has a very nice feature to capture our Bluetooth traffic for us. We simply just enable it through the phones. So, and then once we will save it to a log file called BTLE snoop, and later we can also use Wireshark just to open it to analyze. Script provided by Chen to do some BTLE traffic replay attack, just to prove that our concept works. So here comes our first video. So I simply using the BTLE to replay the traffic like that. Right? So and replay and open. And I tested another one again. Sorry about the background noise. Okay. Now, however, for now we only get the unlock password, the traffic to unlock the password from our own mobile phones. We need to find a way to sniffing it from the ear. I do think I have some slides missing. Maybe I should check to make sure. How can I? Does anyone know how to go back to the? Oops. No, just yes. Sorry about that. That's right. So we now there actually turns out two ways to sniffing unlock password from the air. We can using passively. We can sniff it passively or active. Now let's take a look how to do it. Okay. Now, when we want to do a Bluetooth security search, the Bluetooth, as I mentioned earlier, is most likely the device you're going to hear first. The Bluetooth is designed by a man called Michael Osman, and the Bluetooth is called Bluetooth Classic and Bluetooth Low Energy, and they cover pH a physical layer and linking layer for us. Also, I would suggest we get 3 of Bluetooth dongles. The reason why is that because BTLE is broadcast on 3 fixed channels, remember I mentioned earlier. We just, but we don't know which channels you were going to use. So we're using 3 of them just to put each Bluetooth on one particular channel and just to make sure we're going to capture those broadcast channel informations. Okay, and one useful application is to use Bluetooth and another software called BTLE together to crack the BTLE pairing key for us. Now, the BTLE is wrote by a guy called Michael Ryan. It's actually targeting the weakness in the BTLE key exchange protocols. So, before establishing the encryption sections, 2 BTLE devices must establish a shared secret known as a long-term key. Now, through the key exchange protocol, the key exchange protocol begins by selecting a temporary key. All value used by and all other used value to use to calculate in plain text over the year, except this temporary key. And now, during the research, I found it's very difficult to sniffing enough pairing packets in order to crack. Even I have 3 of them, but maybe due to the interference, whatever, I only have successful ones to actually crack in the key, which is 6 zeros anyway, right? So it may not be suitable for practical attack, but in theory it works. Now, but again, it turns out a lot of BTLE devices are actually relying on just works. So we don't really need to crack it. We have it already. Okay. So once we know the pairing key, we can use a BTLE sniffing device called TI Smart RF to sniff in the packet between the mobile application and lock. Now, TI Smart RF is a commercial product from Texas Instruments, and it's based on CC254 chipset. Now, it comes with a very nice GUI application called Smart RF Packet Sniffer, and now this Smart RF Sniffer is very easy to use and has provided a very helpful feature. If we simply provide a passkey to the TI Smart here, it will automatically calculate out the long-term key for us, and then we're able to see the outer packet sniffer, the packets here. Again, I would recommend using 3 of them, and then just to monitor all those 3 channels. And as you can see, actually this is the unlock password I captured through the air. Okay. And once we capture the unlock password, we can use BTLE dongle or simply use the mobile phones with a light blue application to unlock it. And here's a video where how we do it. Sorry about the noise. I already stopped using radio demos and stuff. Yeah. One thing nice to notice is that it has a log file to see how many people opened it before. Now we use light blue to connect it to the unlock. And we found the password, and we simply paste the unlocking password to sniffer. Okay, I'll open. Right. the nice thing is because we are actually directly interactive with the lock, there is no lock file. So nobody is gonna know lock has been opened. It's very nice, right? Now, let's take a look. How do we do it actively? Now, in Black Hat 2016, a researcher has released a tool called Gap attack. I don't know how to pronounce this, but it's mainly to do BTLE man-in-the-middle attack. And this tool is suitable for denial attacks, spoofing, and data interceptions. Now, in order for man-in-the-middle attack to work, 2 BTLE dongles are needed, and that's why I suggest we just bought a bunch of them just in case. Okay? So, for our case, one dongle will act in like mobile applications, and another dongle will act as lock. So, and then between these two, they are actually communicating through TCI network. So here's the slides from the picture from his slides. And this is how our BTLE application works originally. So first, mobile application will scanning for a BTLE device at investment. Once it receives what it's looking for, it will stop scanning and connecting to this particular device, and then it will start communicating. And this is what supposed to work. However, since we are going to do man-in-the-middle attack, again, so for example, this one going to simulate the mobile phone applications, and it will advise it's in a very high frequency. So just to make sure our mobile application will connect into us instead of the real one. And also another our example going to simulating lock, right? Now the one thing regarding the BTLE device is once we are communicating, once we are connecting to it, it will stop to advising against. Right. So in this video demo, we're going to use get tag to capture unlock command like we want. Okay. So now the application start running, and we just do the normal way. We're going to unlock it, and as you can see, we already see some traffic from the lock. And now, once the moment I press unlock, we will capture the unlocking command right away. Right. So. Yeah, so it really depends where we prefer. We're able to sniff in it. We're able to do man-in-the-middle attack, right? So, but this is the true RF attack vector. Now, let's take a look. How can we do it in application layers? Now, remember I mentioned early on the dark bomb application has provided an interesting feature that we can share the lock with different users. So this is a very, very cool feature actually. We are able to allow certain users to open the lock that's while we are currently away. But I would really wonder, how does it work and what kind of information has been shared? Actually, sharing procedure is quite simple. When owner decides to share a lock to one particular user, server will send a sharing invitation token to this user. Right? So once and then we accept it. This shared invitation. The server will reply with the lock ID and the types of this account. And when we share the lock with someone else, the owner can they got the capability to shift, to configure a particular time slot to access the lock, or how many times they can do it. Sounds secure enough, right? Now, I wonder how can we bypass this? Okay. Now, before we bypass this limitation, we need to know a little bit more. Here are the procedures that when we try to open the lock, which is shared to us. So first, we'll need to send a request to the server regarding our current account status, and the server will reply us a current status. And here we can see that there's a lock actually currently shared to us, and the access type is always open. And when we try to open the lock, our account will send another request to the server to ask for what's the current unlocking password. Now, if everything's okay, the server will reply us the unlocked password, and then lock will just open. Now, as I mentioned, the lock can also be configured to be opened by a number of times. Now, once all used up, we cannot access the lock anymore. As you can see this example, this access type has become unavailable. And if we still want to try to unlock it, well, we can actually get an error message says there's no unlocks remaining. But here's the catch. Since our request and response are under our control, we can replace the response maybe to something else to see, right? And this video that just to demo how can we bypass the limitation. Okay, let me just play the video next. So you can see right now there's no unlock remaining, and this is the evil one. Again, the account is unavailable. So we enable the lock. And we replace the limitation remaining from 0 to 1, and we send it as a response. See, we now have remaining unlocked. Right? Now, again, we're going to send another request to ask to unlock it. And see, now we got no lock remaining, but we can simply replace the password, unlock password which is got before, and we forward to it. Open. So we have actually turns out we have unlimited access to it. Now, for a short period of time, the .bomb application will keep sending requests to the cloud server to ask to query the current lock status, and server will reply with the information like the latest firmware version and other information regarding the lock. And again, those responses are under our control. We can inject some data to see if we make any difference to the .bomb. So here we are going to try to inject something to the public nodes. And as you can see, we are successfully injecting different strings to the public nodes. And one thing I found interesting is when I insert percentage and it was letter P, and the .bomb iOS application will crash. Now, since this bug will not affect to the Android applications, so I'm not actually sure what the actual cause of this. My original guess is maybe some kind of format strings tag, but my wild guess is maybe something to do with the JSON path library that .bomb iOS application use. So as you see, when I inject to try to on Android, it will not work. It will display correctly. So here's the video how it happened. Okay, so now see crashed. So again, when we do the research, we always need to do other than just attacking one of the application on Android, we may also need to take a look at the iOS application as well, because they may have some kind of different behavior or different vulnerabilities exist, which we won't know without just taking a look at it, right? Now, what else we can do? After we went through all the complicated reverse engineering process, it turns out there's a very simple trick to bypass this lock, just by simply using a string, right? We insert taco, sugar code. No coding, no networking skill whatsoever. Now, therefore, the oldest trick from the book sometimes works the best. So, here's some summaries. When developer mobile applications do consider to securing it, right? Enable things like third panning or using any sort of hardening technique. Also, never completely trust the users. Any input controlled by users from potentially can be manipulated. And also, we need to think like the attacker. Maybe we need to hire the hackers or lock pickers to fully test your product. Right? And again, there are going to be more IoT devices coming, and let's hack them for fun, right? Not for profit. Okay, right. So I'd like to thank my colleagues Xi, Yannick, and Chris, who helped me a lot during the research, and also for reverse engineering fans. Do check out Chris, his project called Jeff. Jeff is a GDB enhanced features. This is going to be very helpful for you when you want to reverse engineer binaries. And also, I'd like to say special thanks to Beyond Security for sponsor my research as well. And they do some monthly disclosure program. If you're interested, do check them out. Okay, questions?
We're taking questions, and we have locks for the first person to ask a question.
I saw a hand over there first. Yep.
So I'll just throw this back to her.
Yeah, just a general question. Do you report any of the similarity to the answers and so what was the reaction?
Sorry,
Did you report it and what was the reaction?
Did you report vulnerability to the vendors and what was the response?
Oh,
Microphone?
sorry.